Hi everyone. We're going to discuss different types of reactions and just do a general overview. Majority of our reactions can fall into 6 categories: combination, decomposition, single and double replacements, and then later, not in this video, we'll look at oxidation and reduction and acid-base, and that's not until chapter or a later chapter. All right, a combination reaction is pretty much exactly what it says. It's when you join two or more reactants and you form a single product. So that's the main idea here, is that two come together and they give you one product on the right hand side. Okay, and so here's some examples. If we take nitrogen and hydrogen, they combine to give us one compound, and that's ammonia. Okay, same with, here's an ionic compound, calcium and bromine transfer electrons to give us calcium bromide. Okay, but the main idea here, you take two things, you combine them together, and you get one product. Decomposition is the opposite. So here you have one reactant and it decomposes, so it becomes two or more products. Okay, so you start with one reactant and you form two or more products. So your reactant is broken down. Okay, so this is the opposite of a combination. Okay, and so here's the exact opposite here. Ammonia breaks down to nitrogen and hydrogen. So you basically, looks like you sort of pull it apart. Okay, a single replacement is when one element replaces another one in a compound to form a different compound in your products and an element. So you get a compound and an element. So if you look here, A replaces the green atoms. So if we want to call those B, so it's like the green atoms get kicked out. So B's get replaced by the blue, which is A. Okay, and so now if you consider the red atoms to be C, you now have bonds with A and C, and B is kicked out. So one element replaces the other. So this starts out as the element, and this is the compound, and now the green is our element, and we have a new compound. So they swap places by a single element. Double replacement is where everything pretty much swaps places. So here green goes and takes place of the white molecules, and the white molecules come and take place of the green molecules. So you have two compounds as reactants, and you form two different compounds in your product. So they exchange, so it's a double replacement. So if you have two reactants, they exchange parts and they form two new products, and these are also compounds. If you have a single replacement, one element gets replaced, but then you have an element left over. Okay, and here is a double because you have two compounds as your products. Here's some good examples. So if you look down here, a single replacement, you have an element by itself. Okay, and so bromine replaces the chlorine, and now chlorine is no longer combined with another element, and so this is a single replacement. Okay, here sulfate, remember that's a polyatomic ion, so it binds with the iron, and then copper is left by itself. In a double replacement, we have two compounds forming two new. So here we swap places. So silver and Ag and the chlorine come together, and sodium and the nitrate come together. Here hydrogen, oops, and the hydroxide come together, and Na and Cl come together. So there's a complete swap there, and you still end up with two compounds. So it's called a double replacement, where this one's a single because only one element is doing the replacing. And that is it. Thank you.